See, if the designer had designed the RC and RE and the VCC to have this load line and set its Q point QA with all these parameters, then this is the DC VCE and IC he had set, right? But for our AC swing, increase in VI will increase in AC VBE, will increase in total VBE, will increase IC, and that increase IC will decrease in VCE. So as far as decrease in VCE and increase in IC, it's okay. But as soon as the negative phase of V input comes, AC VBE decrease will decrease the total VBE. That will decrease the total IC corresponding to the animations shown in the last slide. So that decrease in IC will be providing an increase in VCE. But this VCE increase has a limit to this VCC. It cannot provide more than these voltages, the VCC. Similar is the case when he would have taken load line B with a Q point QB. This Q point QB is more near to the saturation region. So a negative swing in VCE or positive swing of IC will make the transistor to enter into the saturation region and you would be having a clip. So remember, in practical application and simulation, when you are having a negative phase clipping of VCE or positive phase clipping of IC, you are entering into the saturation region. Your Q point is too near to the saturation point. It's not in the middle. And vice conversely, when positive phase of the VCE is clipping or negative phase of the IC wave is clipping, it means your transistor is entering into the cutoff region. It is because your Q point is too near to the cutoff point. So for amplification, remember this point, for maximum undistorted swing, undistorted means positive and negative swing should not be distorted or clipped. Your Q point should be biased at the center of the saturation and cutoff. So this is the cutoff point. And where is the saturation point? Is not this one. This is hypothetical point. Is this one. So in our previous few slides, we have seen that this should be nearly 0.3 volts. So to find a center point, if you want, you have already decided your VCC, then your center point would be VCC minus 0.3 divided by 2. This will give you the center point required for VCE setting, DC VCE setting. So this close the DC analysis, Q point and DC load line. Assignment number 2 already given to you. You had a deadline. Please follow the deadline. Don't try to upload nearby the end time. Please do it as soon as possible. Now you have another assignment. Assignment number 3. You have to take the same circuit as we have just completed with DC analysis and AC operation, not AC analysis. But you have to change RB1. RB1 actually is the same. But you have to take RB2 is this one, RC, RE, VCC, and you have to take this transistor at beta is equal to 300. I had taken the same one. So you have to simulate the previous circuit in assignment number 2 with this BJT as well. And VI 10 millivolt for simulation purposes only. Solve neatly on your notebook. Your section name should be written at top left corner For example, at this slide, this is the top left corner. It should be written like A or B space Muhammad Aqil on each page that you are going to solve this neatly. Then simulate the circuit with DC only and after applying AC. To submit the assignment, similar to the assignment number 2, you have to install any PDF making application in your mobile phone. For example, cam scanner. Take the picture of all the pages of the notebook in which you have solved this example, having your name at the top left corner, and the pictures of simulation circuit and outputs. Make a PDF of it, and the name of the PDF should also be your section and name. For example, B space Muhammad Aqil.pdf. Upload this file until April 13 before the midnight. Thank you very much.